Hello, this is Sigma Bob. In this video, I will be discussing problem 20 from the AMC 10 2025B. We will carefully examine the problem statement, identify the key idea required for its solution, and work through the steps in a clear and systematic way. Let's get started. Here is problem 20 from the AMC 10 2025B. A square has side length 1. Four congruent semicircles are drawn inside the square so that each semicircle has its diameter on a side of the square. One endpoint of each diameter is a vertex of the square, and adjacent semicircles are tangent to each other. A small circle centered at the center of the square is tangent to all four semicircles. The diameter of the small circle can be written in the form root a plus b times root c plus d, where a, b, c, and d are integers. Find a plus b plus c plus d. Find the radius of the semicircles using a tangent distance relationship and the Pythagorean theorem, then use a second Pythagorean setup to solve for the diameter of the central circle. Pause the video here if you'd like time to solve the problem yourself. Now let's go through the solution. Let the radius of each semicircle be r and let d represent the diameter of the small circle in the center. Because adjacent semicircles are tangent, the distance between their centers must equal the sum of their radii, which is 2r. Looking at the right triangle formed by two neighboring centers, one leg has length r and the other has length 1 minus r. Applying the Pythagorean theorem gives an equation relating these lengths. Solving that equation yields r equals root 3 minus 1 all over 2. Now focus on the center of the square. The small circle is tangent to the semicircles, so the distance from the center of the square to the center of one semicircle equals the radius of the semicircle plus the radius of the small circle. Since the diameter of the small circle is d, this distance is r plus d over 2. Using the geometry of the square and another right triangle, the Pythagorean theorem shows that the entire distance can also be written as 1/2 of root 8 minus 4 root 3. Doubling both sides gives 2r plus d equals root 8 minus 4 root 3. The expression under the radical simplifies nicely to root 6 minus root 2 squared, so we obtain 2r plus d equals root 6 minus root 2. Substituting the value of r, we get d equals root 6 minus root 2 minus root 3 minus 1. Rearranging gives d equals root 6 minus root 2 minus root 3 plus 1. This factors as root 3 minus 1 times root 2 minus 1. Therefore, a equals 3, b equals negative 1, c equals 2, and d equals negative 1. Adding them together gives 3 minus 1 plus 2 minus 1 equals 3. So the final answer is choice A, 3.